from creative to abstract, from creative to logic, from abstract to concrete. I made you a promise, and I'm going to wrap this video up. I promised you that I would show you a higher dimensional object. Right? And I probably will start the video with this because it's going to be pretty cool. And then you'll have to rewatch the whole video of me getting to this point in 40 minutes. And I apologize, it was very long. It was very, 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 very lengthy. Now, you start with a point. The point is undefined in mathematics, right? But is it? Because you'll get a lot of different terminologies for what a point is. I'm going to give you my 2 cents. And I'm going to build on this over time. The definition I'm going to give you is not going to be the most accurate one, but we're going to build on it. A point is going to have 2 states: abstract point, concrete point. Abstract point and concrete point. And inside of a concrete point, you get a real point and, wait for it, polygonal point. An abstract point is undefined. An abstract polygonal point describes nothingness. An abstract polygonal point describes nothingness. A polygonal point is a Cartesian coordinate. Of space. A Cartesian coordinate of space. This would be really cool if I could actually spell. But since I can't, I'm just throwing some words up there because, like I said, I'm just doing this to keep your attention. So a polygonal point is a Cartesian coordinate in space. A real point is a location on a number line. An abstract point is undefined. It could be whatever. It could be the period at the end of a sentence. It could be whatever you need it to be. Those are going to be fundamental components of points. My 2 cent point is an abstract polygonal point which describes nothingness. Okay. Alrighty. Let's do this thing. 0 dimension equals abstract polygonal point. It's undefined. It has it has absolutely no Cartesian coordinate relationship. It exists nowhere at no time. Nowhere at no time. Nowhere. No time. Nowhere, no time. Oh, and I'm going to represent it this way. 1 dimension. A real point. And what was the other one? I forget the other one. Polygonal point. One dimension. 1 dimension at a point is a real point. If you draw a number line, applying that number line, the relationship between here and here gives you that point. If this is an inch, or a yard, or a mile, or a light year, and this is also the relationship between those two, you use fractions to define that location, which gives this real point an abstract or concrete relationship, and a polygonal point, it would have Cartesian coordinates. Right? Now, that gives us one dimension. Now we're going to go 2 dimensions. 2 dimensions. 2 dimensions are both length and width. That's what we were taught. That's what we're taught. We're taught that something must have length, something must have width to be 2-dimensional. The most basic and fundamental 2-dimensional object is a plane. But a polygonal point on a number line has to have a relationship with 2 other reference points relative to each other to be defined. So if you have a line segment A, B, C, then this point is defined as, how am I going to write this? Because it's actually, how do you do it? The name of the line equals A, B, C. So this point has to be 1/2 B, 1/2 C equals 1/2 B, 1/2 C. I think that's right. That's how you would name it. Man, it's been so long since I did geometry. It's like it makes sense in my head, but when I try to actually communicate it, I lose something. So let me try it this way. If I have a point on a number line at location, okay, I remember now. This is where I made my mistake. Suppose we use this X and Y, and then we do this. We do -1, we do 1, and then we do 0 on the X coordinate, right? So now our polygonal point is exactly X equals 0.05. We'll say it's here. So because we're using a Cartesian plane, you name a line segment is named by its points. This is line segment AB, right? Line segment AB, because the 2 points that define it give it its name. However, on a Cartesian plane, the coordinate system is X. So this is the dimensionality of the line segment. So you have a 1-dimensional line segment, which is named AB, right? Right. So now, it's -1, X, Y. So A, B, C, D. So now you have a 2-dimensional object with the name A, B, C, D, right? And then obviously if you extrapolate up again, you get a cube with 6 sides. The cube has 6 sides and 8 coordinates, so obviously we need 8 characters. So we have A, B, C, D, E, F, G, H. Right? Okay. Good job, Paul. You've taught us things that we pretty much already knew, but you haven't actually gotten to a fourth dimensional object in a three-dimensional universe. The tesseract. It's 4D tesseract. It's this really fancy, might not even be able to draw it. It's this really, really fancy abstract idea of a 4D object in 3D space. No, this is not the 4D object that I'm going to show you. This is the one that we're sold in class, because a three-dimensional object has all these fancy sides, and a hypercube has sides of cubes in four-dimensional space. Right? Ready for this? Don't blink. Boom. This is not a curve. This is a fourth dimensional straight line. It's a fourth dimensional straight line. Because a straight line exists on the x coordinate and only has one Cartesian location, right? It only has the one Cartesian location, x equals 7. If you're going to draw a fourth dimensional object, right, then x becomes an abstraction of two Cartesian locations. Let's say positive and negative, right? So this straight line has two Cartesian locations. So if you were to put x at 7, let's say that this is 7, then you need to know its negative x7 location and its positive x7 location to define it in 4 dimensions. Because this line is what they would be learning. If I was a fourth dimensional math teacher and I was trying to teach my children about straight lines, this is what our straight lines would look like. Our straight lines would look like this. Because if I drew another line like that, they're parallel to each other. They are both straight lines which are parallel to each other. And so our math would include these two Cartesian locations because I can move up, I can move up and down, I can move left and right, I can move forward and backwards. But I should also be able to move in a fourth direction that is impossible to describe in our universe. So if I were to move in a straight line and I had an extra range of motion, this is how it would look. Because a straight line, there is no extra up or down range. You can only move left to right. But because I'm a higher dimensional being, I can actually move in another orientation that we in this dimension don't have access to. So we're restricted. We understand that if we move, I understand that if I move left to right, then that's normal. And I understand that if I move forward to back, I move in another dimension. But if I was a fourth dimensional being, I would understand that I have access to two Cartesian locations to the left and to the right. So we probably we always say go left or go right. They probably would say go positive left or negative left, because they would have that extra orientation, you know. But this is what I love to do. I don't want to get on the internet and have a debate about maybe or maybe not God exists. I would like to talk about stuff like this. This is really what I find fun. And the problem is that when I put this out there, people are going to tell me that this is wrong, that it's not correct, it's not accurate, you're doing the math, the science wrong, that's not true. But then you can flip over to another channel and someone else can say the same exact thing. And they're like, yeah, that makes sense. That's really, and the only reason why is because they've sold you on your emotional disposition instead of the logic. And it's unfortunate that putting on a show is still more important in our society than actually conveying understanding and reasoning. And I know I did a poor job of conveying understanding and reasoning. You're right. But if I don't actually make an effort, I will never learn how to do it. And this is the only way that I can do it. This is the only way that I can communicate my understanding. Because taking the time out to try to put it into concrete and more, put it into a format that will better serve as a medium for you to understand, it'll just turn out to be just like everything else. So this is going to work better for me. You know, like, if I say that nothingness exists as a location of nowhere and no time, and then I draw an abstract point and say that's nothingness, you're like, well, you just contradicted yourself. But the question you have to ask yourself is, why do you perceive nothingness? If it's not something tangible, then why is it so tangible? Is it abstract or is it concrete? And it's from those type of thought experiments that I grow as an intelligent entity. Christianity and other religions and faith will tell you, well, that's just the devil trying to trick you. You need to just continue to be compliant to societal, to social norms, you know. I'm not going to rant and rave about religion, but I'm just saying that to me, this is more realistic. Understanding nothingness seems to be a better pursuit of my time and my intellectual endeavors than trying to understand the complexity of a contradictory entity like a God. The closest thing that we have in our universe to God is the universe itself. The universe embodies all the actual principles that we define a God as having. It's all powerful, it's present everywhere, it knows everything. And since it doesn't hate us, it's omnibenevolent. Because it absolutely loves us by not loving us, by not being hateful. You read books where God shows you how much it loves you by destroying everything. That's not an act of destruction, isn't love. But it's a really good way to teach someone to be appreciative of an oppressor. That's just my opinion. If I'm punching you in the face every day and telling you that I love you, there's something wrong with that, you know. But that's the way we're taught. That's the way we're raised. So this video has officially reached the 1 hour mark. So with that, I'm going to close it out, and we'll work on the next one. And as always, my name is Paul Emerson, and I have just given you my 2 cents.